Hi guys, welcome back. Here's example number 3 from section 5.1. We're moving on to co-function identities and odd and even identities. So co-function identities, what makes two things co-functions? Well, they're co-functions if they're part of the same triangle. So let's look at this. We're looking at, let's call this guy alpha and this guy beta. So this is my x, this is my y, this is my 1. What would cosine of alpha be? Sorry, let's go with sine. What is sine of alpha? Would be y over 1, opposite over hypotenuse, so it's just y. Now if I asked you what is cosine of beta, what's cosine of this angle here? That's going to be adjacent over hypotenuse, or again, y over 1. So notice these two guys are equal to each other. Sine alpha is equal to cosine beta. And then you ask yourself, well, how does alpha and beta relate to each other? Well, notice they're both a part of this 90-degree triangle. So would you agree with me that alpha is equal to 90 degrees minus whatever beta is? So my alpha is equal to 90 degrees minus beta. So I'm going to go plug that in here. So sine of alpha, but we said alpha is 90 degrees minus beta. So you want to cosine beta. Well, if we talk about 90 degrees in terms of radians, we're talking about pi over 2. So that's where we get these formulas from. Cosine of some theta is equal to 90 degrees, or pi over 2, minus that beta here, or minus theta in this case. So cosine of theta is equal to sine of 90 degrees minus that theta. So they're called cofunctions because you can come up with these identities where they relate to each other. And then the other thing that we have are these odd and even identities. So if you haven't changed it already because you missed class or whatever, I made a huge typo over here. These guys should be positive here and here. And so we have odd and even identities. They're called odd and even identities because we're talking about positive angles, negative angles. So we're talking about, is the function odd or is the function even? So let's real quickly assign function. And I'm going into this much description just because I had a lot of questions of, well, why do these work? So since you were curious, this is our assign function, and this is an odd function. And in case you don't remember, it's odd because it's symmetrical about the origin. So this point here has a negative y value of this point down here. And since it's an odd function, if I look at this value, say this is at pi over 2, if I look at negative pi over 2, it should be at the negative y value. So sine of a negative function is going to be minus sine of this guy here. So this y value is minus sine of this y value. I hope that's making sense to you. Reason why cosine and secant, and these guys are reciprocal functions, same thing works for these guys. I'll let you investigate this one by yourself, but go graph tangent and see why it's an odd function. Let's look at cosine. Cosine starts here and goes down and goes back up, right? And then it goes and does this. So what is this one symmetrical? Assume that this was actually drawn correctly. Is this guy symmetrical about the origin? Is this point referred to something down here? No. This one's symmetrical about the y-axis. If I cut this axis or this graph in half and I folded it in on itself, it would match up equally. And so for even functions, when you look at this pi over 2 and negative pi over 2, so if you look at the positive x value and the negative x value, what's true about their y values? They should be exactly the same. So whatever this y value is, the negative version of the angle also produces that same y value. And so that's why these guys, you can pull out that negative sign, so this has a negative y value, and these guys have the same positive. I'm doing a really bad job of explaining, but hopefully this visual is helping you see why these guys change the signs and these guys don't. That might help you further down the road. It may be a waste, but we'll see. All right, example number 3. You guys got really tripped up on these, they're not challenging problems. I think you're still wondering, like, why do we care? Well, if I want to find cotangent of this angle, and I don't know what this angle is, the only piece of information I have is tangent is this number, I've got to write this guy in terms of tangent in order to use the information that I'm given. So I've got these identities here that if I could make my inside look like this, then I could relate it to tangent and use this information. But if I can't make this look like this, then I can't use this piece. So what can I do to cotangent theta minus pi over 2? I want this guy to be pi over 2 minus theta. In other words, I want to change the signs of both of these. I need this guy to be negative, this guy to be positive. So the way that we learned to do that back in Algebra 1 was to factor out a negative sign. All right, let's check ourselves. Negative times pi over 2 would be negative pi over 2, minus a minus theta would be positive theta. All right, and then our odd even identity, here we are over here, says that if I have cotangent of a negative angle, I can rewrite it by pulling out that negative, and it's minus cotangent of the positive version of the angle. Still not at a point where I've got tangent, but I'm finally at a point where I've got negative 1 times this cotangent. This guy here, from my identity right here, this guy is equal to tangent theta. So this guy is equal to tangent theta. So I could rewrite this as equals at negative 1, not times cotangent, but times tangent, not of this angle, but of theta, from this identity up here. And since I can write it now, I finally have something that just has tangent in it. I know what tangent is, so now I know cotangent of theta minus pi over 2 is going to be minus 1.28. Is that always going to be the case? Nope, it's not always, I think some people thought, oh, well, this was really easy. I'm just going to slap on a negative sign and call it a day and move on. That's not always the case. It only works if we're changing signs here, and the information we're given, these guys are reciprocal functions. But we're going to see in the U-try that it's not always so sweet. All right, so again, starting with cosine of x minus pi over 2, I need it to look like pi over 2 minus x. So this guy here is the same thing as cosine, factoring out that negative, pi over 2 minus x. Now it kind of looks like it. I've got cosine of a negative angle. What does my chart say about cosine of a negative angle? Remember, this guy was an even function, so cosine of the negative angle is equal to positive cosine of the positive angle. So this guy here is equal to cosine of the positive angle. Okay, how does that help us? Well, I've got something that will relate this guy here to sine x. What does it say? Cosine of pi over 2 minus my angle. Oops. Here we go. It's this guy here. Cosine of pi over 2 minus my angle is equal to sine of that angle. So I've got cosine of pi over 2 minus an angle. That's going to be equal to sine of that angle. And we know from the information they gave us, sine x is negative 0.37. So notice this one did not change signs, whereas the other one did change signs. It just has to do with the information that you're given and whether it's odd or even. Try not to get too tripped up on these, but know how to do them. You'll see how it ties into the bigger picture. This isn't one of the biggest things we have to worry about, so I don't want you to get too tripped up on it, but it's good stuff to know. Have a great night, guys.